Okay, good morning. Making this video to go over the 10D notes. The first two problems are just warm-up problems, so I'm not going to spend too much time on that. Um, Here we have a cone, okay, and we know that cone is a pi r squared plus pi r l. We don't know the radius and we don't know the slant height on here. However, the circumference of 43.96, okay, the circumference is 2 pi r, okay? So 43.96 is equal to 2 pi r. Okay. And so what we're going to do is we got to find the radius. Okay. So we got to find the radius by dividing by 2 pi. And we got to make sure we divide that in parentheses. Okay. So we'll divide that by 2 pi to get our radius. And then with a height of 24 and our radius of whatever it is, then we can do that to find a slant height. Okay. So that's just something to help you out with that warm-up problem if you need it. Okay. Pause the video if you need to do those warm-up things. And then down here to these notes. Okay. Sphere. On the 10A notes, I gave you guys a formula for a sphere. It was kind of off to the side because it wasn't on the original notes, but it was on the video. The surface area formula for a sphere, okay, is 4 pi r squared. It's 4 pi r squared. Okay. Now, a hemisphere, okay, is half of a sphere. So a lot of us think that, okay, with a hemisphere, it would just be 2 pi r squared because it's half. Okay. However, that's not the case in a hemisphere because in a hemisphere, we have half of a sphere, so half of sort of the outer thing, okay? Okay. But we also have something showing now. We have that circle that is showing right there, which is not showing in a regular sphere. So that circle is not on the surface, it's inside the sphere because it's not part of the surface, okay? Same with that circle right there, okay? That circle's not in there, okay? However, in a hemisphere, when a thing is cut in half, we have to account for that. So we need to add another pi r squared, okay? Because circle area is pi r squared. So, 2 pi r squared plus pi r squared. So the surface area for a hemisphere is really 3 pi r squared, okay? We have 2 pi r squared, which is sort of your outer shell, okay? Plus the pi r squared, which is a circle in the middle. If you want to think of an orange, okay, if an orange is a full orange, okay, the surface area is 4 pi r squared, which is pretty much the whole orange peel, okay? However, when you cut an orange in half, okay, you have half of the peel, but now you have the circular core of the orange where you'd actually squeeze and get the juice out, which is showing, okay? It's now on the surface, so that's what we have to account for with that, okay? So sphere, 4 pi r squared, hemisphere, 3 pi r squared. Okay, last thing I want to spend a little bit of time on to find the surface area of a composite figure. So we have two figures sort of put together. Okay, and so there's a couple different ways to do it, but I would like to go think of it in a very, very simple way here. All right, and what we're going to do is we want to find the surface area of both figures. Okay, so we're going to find that surface area of both figures now, but there's something that we're going to have to subtract. Okay, because if we're looking at this thing here, we're going to do an example here for a minute. If we find the surface area of both figures, well, both the rectangular prism and the trapezoidal prism have this rectangle here as part of their surface area. It's the bottom of this trapezoidal prism and the top of this rectangular prism. Well, when these two figures go on top of each other, okay, now all of a sudden this thing is not showing from the trapezoidal prism, and this thing is also not showing from the rectangular prism because they're on top of each other, okay? So we have to subtract the two overlapping areas, okay? We need to subtract the two overlapping areas. So when we find the surface areas for both of those, okay, we're going to subtract the overlapping area twice. All right, so let's start with the trapezoidal prism right here. So if we do the trapezoidal prism, and we could net this out if we want to. All right, so we have 2, 2, and each of these sides is 2.5. All right, and the base is 5 right there. All right, and then 6 is the distance from base to base, so that's there. All right, so as we copy all this stuff down, so the 2 can come here, the 2.5 can come here, and the 2.5 can go there. All right, and 6 is here. All right, so starting with our trapezoid here, we have a 2 by 6, which has an area of 12. We have 2.5 by 6, which is 15. We have 6 by 5, which is 30, which is underneath. And we have 6 times 2.5, which is another 15. Okay. Trapezoid, base is 5. The other base is 2, so 5 plus 2 is 7. 7 times 2.5 is our height. All right, so we have to do 7 times 2.5 divided by 2. Okay, which is 8.75. Okay, because the little height there is 2.5. All right. So adding up all of our stuff, we have 8.75, and we have 2 of those. And we have 15 plus 30 plus 15 plus 12. So this trapezoidal prism right there should have an area, a surface area of 89.5. Okay. So that's 89.5. Now we have the rectangular prism underneath here. Okay. And if we want to do a net for that, we could. I'm just going to do surfaces. So we have 3 by 5, which is 15, and we have 2 of those. All right. And we have the 3 by 6, which would be this thing. So we have 2 18s. Okay. And then we have 2 of the 5 by 6 on the bottom, which is 30. Okay. So we have that rectangular prism there, which is 2 times 15, which is 30, 2 times 18, which is 36, and 2 times 30, which is 60. So this rectangular prism is going to have a total surface area of 126.
Could I bother you for some coffee if you have any?
All right. So the rectangular prism has an area of 126. Okay. So we'll add the 89.5. And we'll have 215.5. Okay. So we added the surface area of both figures. Okay. We got 215.5. Okay. 89.5 plus 126. Now we got to subtract the overlapping areas. Well, the overlapping areas are the base or the bottom of the trapezoidal prism, which is, that rectangle of 30 right there. Okay. This pink rectangle here of 30. And we got to subtract it twice. We got to subtract 2 overlapping areas because we got to take it away from the 89.5 and we got to take it away from the 126. So we're going to minus 30 and minus 30, which is really minus 60 from 215.5. And so our final surface area here is going to be 155.5 centimeters squared. Okay. This is probably the hardest one in here. Okay. Trapezoidal prism. And so um, so that's that. Hopefully that'll give you kind of an example. I think it's the easiest thing to do is find a surface area of both figures, subtract 2 of the overlapping areas. Okay, so we subtract 2 of the 30s, subtract 60, and we get our final answer there. Okay, so you could try these other 2 problems out. We'll go over them towards the end of the period, and let me know if you have any questions or concerns. You take care and have a great day.